Okay, so in chapter 2, we're going to be talking about descriptive statistics. So remember the difference between descriptive statistics and inferential statistics. Descriptive statistics is when we're dealing with gathering our data, doing graphs, doing different measures to describe our data. So there's lots of different things we can do with descriptive statistics. But that involves collecting our sample data and then describing it. We're going to do different types of graphs, and we're going to calculate different summary measures, some measures of center, some measures of variation. So the first graph we're going to look at is called a stem and leaf display. The stem and leaf display comes from what's called exploratory data analysis. And what the stem and leaf display will do is detect patterns and extreme data values, and it really does provide an easy way to sort our data. So we want to look at how to do the stem and leaf display. So we're going to break our digits into two parts. One's called a stem and one is called a leaf. So we're going to do this example here. Okay, this is from the OpenStax textbook. So it says, for Susan Dean's spring pre-calculus class, scores for the first exam were as follows, from smallest to largest. So it's already sorted from smallest to largest. Okay, now when we look at these numbers, keep in mind this is not the scores for our statistics class because most of my students will not score this low. This is for some Susan Dean's pre-calculus course, okay? So now all of our digits, they range from 33 to 100. So we're going to break the digits so that the tens place value is going to be our stem and the ones place value will be our leaf. So what we do is we draw a straight line, and on the left-hand side here we write in our possible stems. So for any number in the 30s, the stem would be a 3. For any number, whoops, sorry about that. I don't know what happened there. For any number in the 40s, the stem would be a 4. And we go right in order. We don't skip any numbers. So we're going to do 3, 4, 5, 6, 7, 8, 9, and 10. Now remember, even if we didn't have any numbers in the 90s, we still have to write the 9 there, okay? So then we look at the numbers in the 30s. 33 has a leaf of 3, so we write that there. Now we do the numbers in the 40s. We have 42, we have 49, and we have 49. Okay, and then we're going to do the numbers in the 50s. So we have 53, we have 55, and 55. Now you have to be neat when you're doing the stem and leaf displays. We can't crowd the leaves. We have to make sure we have them in columns because this gives us an idea of our shape. Okay, let's look at the numbers in the 60s now. We have 61, 63, 67, 68, 68, 69, and 69. Now we do the numbers in the 70s here. So we have 72, 73, 74, 78. And see how I'm keeping these in columns and keeping them lined up. Don't crowd the numbers. Let's do our 80s now. Let's look at the 80s. 80, 83, 88. Looks like we have 3 88s, right? And then we have 90, 92, 94, 94, 94, 94, and 96, and then we have 100. Okay, so what we do, so this is our stem and leaf display. Then what we need to do is we need to make a key. So off to the side here, I'm just going to pick any number. I'll use 33. 3-3 equals a score of 33. Okay, So if it would have equaled percent or inches, we put the unit here. This is called our key. So make sure you write a key for all your stem and leaf displays. Now, this won't be as important on the homework. I don't think they're going to ask you for this, but when I ask you to do the worksheets or the midterm, make sure you show the key. Okay? Now, the other thing we can do, and I don't know if no, we'll turn there. If we turn this on its side and kind of look at it here, and picture these as bars, it gives you an idea of the shape. When we do histograms a little bit, if you just look at what I have highlighted and kind of turn it on its side, you can see, and if let's say we were actually to even do, let's say a little, kind of curve over it, it kind of gives you an idea of the shape of our data. Okay, and we'll talk about that when we do histograms in just a little bit. Okay, let's look at this example. The data are the distances in kilometers from a home to local supermarkets. Create a stem plot using the data. All right, now these data have decimals. We have 1.1, 1.5, 2.3, 2.5, 2.7. So when we do this stem and leaf, our stems are going to be in the 1 place value, and the leaves will be the first decimal place. So it looks like we're going to go through 1 through 12 here. So I start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, just because we skipped some numbers here, we still have to put them in our stem and leaf. So this will show us if we have potentially outliers. So 1.1, we put the 1 here. We don't have to put the decimal in, and then we put the 5. 2.3, we put the 3, 2.5, 2.7, 3.2, 3.3, 3.3, 3.5, 3.8, 4.0, 4.2, 4.5, 4.5, 4.7, 4.8, 5.5, 5.6, 6.5, 6.7, and then 12.3. And now if we write our key over here, we just pick any number. I'll just pick 2, 3 equals 2.3 kilometers. So that's what the key is important, that we put that unit and we show what it equals. So now this is where we're showing where that decimal is. That's why we don't have to put the decimals over here in our plot. The other thing we can see, again, if we kind of look at the shape of our data here, it's a little bit left skewed, and we'll talk about that in a second, but we also can see that this 12.3 looks to be an outlier. So this could be an error, or it just could be an outlier, one supermarket that's further from the home. Okay, other than the stem plot, there are 2 other types of graphs I just wanted to quickly go over in section 2.1. The first one is called a line graph. The line graphs, it's just another graph that shows some specific data values. So here we have a survey where 40 mothers were asked how many times per week a teenager must be reminded to do his or her chores. The results are shown in the table. So 0 times, there were 2 teenagers that did their chores and didn't have to be reminded. Shocking, right? There were 5 teenagers here that only had to be reminded once. There were 8 teenagers that had to be reminded twice. There were 14 teenagers that had to be reminded 3 times. 7 teenagers that had to be reminded 4 times. And 4 teenagers that had to be reminded 5 times. So then basically we just plotted those points here. The number of times teenagers is reminded is along the horizontal axis, and the frequencies are always on the vertical axis. Which, the most teenagers need to be reminded about 3 times, it looks like. Another type of graph is called a bar graph. The bar graph is used for qualitative data. So when we're dealing with qualitative data, we use a bar graph. In just a little bit, we're going to talk about histograms. They look like bar graphs because they're but the difference is their bars will be touching and they'll be dealing with qualitative data. The reason this one is considered qualitative, even though it says age groups 13 to 25, it's counting how many are in that group. It's not measuring their age here, it's just counting them as a group, which is more like qualitative data. And then we have a group 26 to 44. Here's the number of Facebook users, and then 45 to 64. And we show the proportion here. They have the numbers here, but on this bar graph, they have the ages on as a group, 13 to 25. And then they have the proportion up here on the vertical scale. Now we could also do this as a pie graph. As long as our proportions total 100% here, we can also do what's called a circle graph or a pie graph, where we use, 45%. I'm going to estimate here. 45% are ages 13 to 25. Let's see, 36% would be ages 26 to 44. And then, of course, 19% would be ages 45 to 64. So we can also do a pie chart or a circle graph. Now, computer systems we use today make these a little bit prettier and a little more exact, right? Okay, any questions so far?